Um, really quick, let me just make sure that I have this thing, because I have all my notes here. Actually, you know what? We'll just go for it. Good? Cool. Hi, my name is Brian, and today I am going to be talking to you guys about some pretty random stuff. So let's see if this works. No, it doesn't work. Great. So here's the first random thing I'm going to show you. It's pretty random. Yeah, great. Next thing. I expected maybe a laugh from that. Thank you so much. So yeah, the first thing I'm going to ask you guys to do is just in your head pick a number between 1 and 10. A random number, of course. You don't have to tell me. Just leave it. Just leave it. But the funny thing about asking this question, asking people to come up with a random number, is that most of the time they kind of tend to gravitate around a couple numbers, or one number specific, which is 7. Right? And it's weird because I'm asking you to pick a random number, and you tend to gravitate towards something completely not random. Right? So why does this happen? That's a great question that you just asked. So here is, just to give you a little piece of proof, this is this study that this guy from Amazon did, and he basically just went out and polled 1,000 people. And you can see that there's like a heavy bias towards 7. So why is it? Well, there's something about a few different numbers that just don't feel random, right, to us, right? There's like 1 and 10, they don't seem random really necessarily because they're at the front and end, like, so, I don't know, we kind of start to assign properties to certain numbers that, whether or not they feel random, right? So, why am I telling you this? I guess the point of what I'm saying is that picking a random number is not as easy as it may seem, even to people who should be perfectly capable of doing something like that, because because we're not machines, and machines are deterministic, which means essentially that they cannot produce, so they don't have any randomness built into their specific system, right? So any future state, any development of any future state of theirs can inherently not be random. It can only be produced by whatever you tell it to do, right? So, yeah. One moment. So, up here we got Brother Edvin in the middle squares, which I think is a fantastic band name. And this guy, Brother Edvin, right here, came up with this method called middle squares, the middle squares algorithm. And he came up with this in like 1250, something like that. So it's pretty impressive that he came up with this thing so long ago. Essentially what he's doing is he's trying to create a random number, basically to, because he was looking for a way to produce consistently random numbers, because he was trying to help with a problem, which was people like rigging dice and trying to win all sorts of things by rigging dice. So what he basically did, as you can see here, he takes this 6-digit number, he squares it, and then he takes the middle 6 digits and considers that his new random number, right? And the cool thing about this is he can keep doing this, right? He can keep taking this, he can square it, take the middle 6 digits, and continue coming up with new random numbers, or numbers that seemingly are totally different and unrelated, right? And my phone, hold on. Great, so there we go. Cool, so this is, like I said, a pretty advanced method for something for somebody to come up with in the 13th century, but it has a few shortcomings, including very short periods, right? And a period, as many of you probably know, is simply the amount of iterations it takes to go through an algorithm until it starts repeating. So one kind of funny example of that is 3,792. So you can see here, you square it, and the middle 4 digits are 3,792. So, I mean, its period is immediate. These 4 numbers here continuously repeat themselves when we are going, essentially, through a middle squares method. Great, so another shortcoming is that sometimes if you have too many zeros in your seed, you start to see a bit of an annoying thing start to happen, which is that the number gets shorter. So originally we started off with a 6-digit seed, now we have a 5-digit seed. And what this does is it eventually regresses down to 0. So after a while, we're not able to continue repeating. We're not able to continue on our journey towards randomness. So why is this important? Random numbers are used constantly. And as Debanshi was talking to us a little bit about earlier, very important in cryptography and in a whole slew of different things. One thing I'm going to talk about now is gambling, right? So online casinos, for instance, need to use random numbers to basically say whether or not, or to instruct cards as far as, what cards are going to be shown, what roulette number is going to be displayed, et cetera, et cetera. So if you are producing a random number, or you're producing a series of random numbers, it's increasingly important to have very long periods, because if you don't, over time, a machine that is maybe paying attention to whatever numbers these are is going to be able to see, is going to be able to detect a pattern and figure out what the next number is going to be and win all of your money. And you don't want that if you're a business. Great. So, oops. How do you fix this problem? So if you're using a method like the middle squares method, essentially all that you would have to start doing is understanding what these cases are, right? What these cases are that's going to shorten the period, that's going to make it more easy for a machine to predict what the next number is going to be, right? So you have to eliminate these certain cases, like the ones where there's too many zeros, or when it's one of those specific numbers that has a very short period. However, that has a big problem in that it makes the numbers that you're producing much more predictable. And any sort of computer that is, like I said, paying attention is going to really easily or much more quickly be able to figure out these weak points in your algorithm, right? And in dice, for example, like if you roll a single dice, it's a perfectly random number, right? Because all 6 numbers have a equal probability. But if you have 2 dice, it has a Gaussian curve towards the number 7, right? Which is why craps is structured the way it is. So we have Bruce Willis here, and he is in this movie, of course, Die Hard, and one of the main batteries of tests for randomization, less excitingly, is also called the Die Hard tests. So most of these kinds of tests essentially involve taking an algorithm and producing a huge number of random numbers from them and plotting them all on a diagram, and basically seeing how they're distributed, because it becomes pretty easy to tell, if there's, numbers getting bunched together or something like that, and yeah, cool. So we've talked a little bit thus far about the seed. Most of you know what a seed is. We also, when we're talking about crypto, we've definitely covered that a bit. But like I said, as you all know, a seed is the number that initiates a pseudo-random number generator sequence, right? So if we have a random seed, a truly random seed, essentially what we can do is use even pretty rudimentary pseudo-random number generators to produce a truly random number. However, a computer cannot necessarily, or cannot at all, produce a random seed by itself. Like, it has to receive some sort of input from its user, right? So, cool. So by taking stimuli from the world around us, it's not entirely difficult to produce these random numbers. However, so that's where being a human is better than being a robot. So one example of this is it's been actually happening for thousands of years is Chinese fortune tellers predicting with the I Ching. I'm not totally predicting the future or predicting fortunes with the I Ching. So I'm not entirely sure how the I Ching works, essentially, but it's actually really interesting that they use modulo to recursively generate random numbers based on the falling of sticks in certain patterns. It's kind of cool. So taking it back to computer programming, a question that you might have is, okay, so we use these certain random number generators. This is a pseudo-random number generator, of course, because it can't just produce a random number because you ask it to. So how random is this number? It turns out it's not really that random at all. In fact, it's not cryptographically secure at all. It essentially, what math.random does is it takes the seed of the current time in milliseconds, and runs it through a series of algorithms which change now and then, and produces a random number. So, and this is essentially, what the seed is for a lot of different pseudo-random number generators. Milliseconds, TV static, nuclear radiation received from specific or from different kinds of stimuli. And here is a little bot, which is essentially, it's called the Flying Stone Trio. I forget the name exactly. And it essentially detects noise and then will produce a random seed for you. And it's really cheap and easy to use. That is my talk. Thank you so much for listening, and have a good day, I guess. Any questions? Iris.